Hello, boys and girls. We are back at it again. Today, uh, during the afternoon, I already worked on a couple of problems. It's 11:56 p.m. now. We back at it again. So right now, I want to go through two things. Um, I want to walk through 1475 final prices with a special discount and the shop stack solution. I came up with a solution, but it's not the stack solution. So I want to work on that just to step through it. And another one that I want to do is 496 Nick's greater element one. Again, for that one, I came up with a solution, but it's not the solution. So for this one, I brute forced it using two for loops, and obviously this is not the best because it's ON time complexity, right? Which is pretty bad. So yeah, let's try and figure out what is a better way to do this, right? Here, use brute force for the ith item, blah, blah, blah. Right, okay, so, and then another one says monotonic stack, right? I don't know what this one is. Don't know what this is. Okay, let's look at this. Um, so, while stack is not empty, and in the back of the stack is bigger than prices I. Prices stack not back. Let's see if it works. Okay, it does work. Okay, a great, much better solution. Oh, not even that bad. It's not even that good, actually. But let's try and understand it, right? Let's try and understand it. So let's say prices right now is this, right? And then I create another stack for I equals to 0. So I'm iterating through. So here I'm iterating through prices, right? While stack is while stack not empty and what? And prices dot stack back. What does vector back return? A reference to the last element. This I don't understand. What does prices stack back mean? Prices stack back. The index is stacked up back. Oh, okay, stack. Okay, okay. So stack is currently empty, so I skip this, and then stack will push back. So it's this, right? And then now I equals to 1. And then now stack size is not empty, and prices stacked up back is 0, which is 8, is bigger than, is it bigger than 1? It is bigger than 1. Therefore price is 0 minus that. So it will be 4. Stack the pop back. Boom, fuck you. And then it becomes 2. Okay. And then is this bigger? It's not bigger, right? Price is stacked up back, which is 1. Is it bigger than 2? It's not. So you just append this, right? I equals to 3. Uh, is this one bigger than this one? It is. So this one becomes 4. Stack, you pop it, and then you push 3. 4. It's 3 to 4. It is bigger. It's 2. You pop this. 4, 5. You're comparing 4. It's not bigger. 5, 6. 5. Right. 4, 4, 2, 2, 3. Wait, what? So we just push it, and then I equals to 1. 0 is bigger than 1. So price is stacked up back, which is 0. So this becomes 4. And you pop it, and then it becomes 1. And it becomes 2. Price stacked up back is 4. Bigger than 2? Nope. So push back 2. And then I is equals to 3. 2 while stack size. Price stack back 0, 1, 2. Right? Bigger or equals to I. Yes. 4. What? I don't get it. 0 and 1. Right? I get it. but it's not. Oh, wait. 0 is bigger than 1. 1大过等于 2. Well, it's not. I don't really get it. Okay, whatever. I mean, it's fine. Let's go to the next one. 496. And then I'm gonna work on another problem. Oops. Anyways, yeah, this one is not the one I wrote. The one I wrote is this, which is very trash, as you can see. So this one I really want to understand. So let's say it's this, right? So for num and nums 2, which is a bigger one, Okay, I understand the intuition. Well, a stack is not empty, and the stack on top is smaller than number. Map of the top number. But I'm going from left to right here, right? So there's my stack. I'm pushing one, and then now it's three, and my map. Top, which is one, is smaller than three. Therefore, map one is to three. And then you pop it, and then you push three. Three is four. Therefore, three, four, you push four. Four is not bigger than two. Therefore, you push two. That is a stack, right? And then four, num one, nums one I. So you're iterating through nums one, four equals the map count. If there is a map count, then it's the map count, or else it's negative one. So it's negative one. One will be negative one, three, negative one. Oh my God. Yeah. Jesus. Let's see. So let's say if it's two and four. One, two, three, four. Two and four. Stack would first be number two, right? Would be number one. Two is bigger than one, so one would be two. Push this. Three is bigger than two, so two would be three. Push this. Three to four, you push this. And then four is not bigger than four. Oh, you already pushed it. Okay, so yeah, okay. Yeah, makes sense. Okay, I understand how it works. Smart. That is very, very smart. Yep. Very, very clever. Okay. All right. Let's do another problem. Let's do one problem and then call it a day. So for this one, I want to do some stack one or some Q one. I do want to do Qs. Let's go for an easy one. Let's do this. Okay, this one I can't do. I don't know what this is. What about this I get it. I okay, so now I have everything in the queue. This is the initial position. If if front equals to 1, then you increment seconds and pop it. Else if else -1, put it in the back of the queue, and then Pop it. Still increment seconds. But then this is while while the pointer there should be an end pointer while k bigger than 0. This stuff should happen while k is bigger than 0. Can I just create a reference? Can I create a reference to an element? So it actually pops out, then it will decrease. I think it's something to do with the size of the tickets vector. And decrement the number of tickets for each oh. K equals to 2, K equals to 1, K equals to 0. On a line, then I have to go through it twice more. Just add it and I pop it. Then then I run it however many times. Let me try. I don't really know how to do this. 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 Second day I tackled this, I still don't know how to do it. I don't know. I really don't know. I really want to know the answer, to be honest. Um, should we? Should we just look at it? Lowest of keys. Lowest of keys. Lowest of keys. Should we do this? It has to be some sort of map thing, right? Yeah. Let's see if there is an easier question for me to do, 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 to do. What is this? I'm thinking something like a partition. So, um, I just traverse it in reverse, right? Um, because vectors support negative indexing. Undefined. Lemma. If it's unequal, I want it to change, right? Um, Mm. And I equals 0. And I of 0, I is smaller than nums size plus I. Um, if if nums I is not equals to value that I would want it to change. Nums mid will be equals, okay, that's easier to understand. Nums top will be equals to nums I. And then what will happen is nums top and the top will increase. And then pointer will just flow forward. Flow forward, flow forward, flow forward, flow forward, flow forward until everything switches, right? And then here, nums. I think something like that. No? Something like that. I said to return top, right? Um, Yeah, this one I used the partition logic from Quicksort. Just switching all the numbers that are not equals to 2 on the left side, and then not equals to value on the left side and everything else on the right. I don't know if this is correct. It worked. So yep. Okay, yeah. Same idea. Okay, well, I do want to figure out how to do this. I don't think I can figure it out myself. So I'm just gonna look at the solution. At the solution. Boy, what? Boy, what is this shit, bruh? Okay, so you don't put it in the queue. Um, and then what's the logic in between here? What is the logic? Ugh, why is this so ugly? Okay, there we go. For ni equals 0 and smaller than ticket size. So you're iterating through ticket over here. And then if I is smaller than equals to k, meaning it's the people before the homie that we're looking at, then you're taking the minimum of else, then you return seconds. What? If I is smaller than 0, sure, then I'll take the minimum of tickets I and tickets K, because that's one person each, right? Let's say this, right? So I have 2 through 2 here. I is smaller than K. K equals to 2, right? I is smaller than equals in seconds plus or minus, so it's 2 seconds. I equals to 1 is most smaller than K. Seconds plus or minus minimum. Tickets I, which is 3, or tickets K minus 1, which is 1. And then I equals to 2, which is equals, then you can take 2. I don't understand this. Yeah, well, the selected person will at most buy the same ticket as the person in index K. If they should buy more tickets, person K will buy his ticket before that. Sure. Oh, okay. This makes a lot more sense. Okay, now I understand it. I'm gonna write it tomorrow. So I'm gonna call it a day here. All right. Peace.